So good evening, everyone. Welcome, Caleb, Success, and John. Welcome you all. Welcome to uh, today's class. So, like last time, I told you that I'll be looking extensively at addressing and subnetting. Right? What is an IP address? An IP address, known as Internet Protocol, is a unique identifier number assigned to every device connected to the internet. An IP address definition is a numeric label assigned to different devices that use the internet to communicate, right? So now we have two types of IP address. We have IPv6 and we have IPv4, right? IPv4 is dotted decimal. So because of the computer only understands binary signals, right, which are 0 and 1. So for us to be able to, for it to be able to communicate properly, data is being broken into bits, right, in smallest units, right? That's binary. So since it understands 0 and 1, that's what we now have. I think IP address has about 32 bits. Then IP address have about 32 bits, and hope you hope you guys can hear me properly and you can see the screen. Can you see the screen and can hear me properly?
Yeah, we can see and we can hear.
Hello, can you hear
It's
me
breaking,
properly
but
and you
I
can
can
see?
hear you now.
Okay. So yes, IP address are broken into bits. Then we have then I think a normal IP address, that's IPv4, is 32 bits, which breaks down into what we call 4 octets. 4 octets is to break down the significant number into 4, because if you count, each binary will be leading to 32 total number of binaries, which includes 0, 1, 0, 1, 0, 1. So now for us to be able to break them, we assigned eight numbers to each octet so that we can easily convert them. That's why we have the total number of IP address we have is 0 and 255, I think. Yeah, 255. So it's broken down into different units so that you can be able to understand it when you see it, right? So IP address is internet protocol used to connect to the internet so that you can communicate properly. So another thing is that yes, we've defined IP address. So we have public versus private IP address, right? Public are the ones you see externally, right? Yes. Then we have private address that are internal. So the difference between these two is that private IP address is unique to a device, while public IP address is unique to an entire network. So the internet in which we use to connect to the when we are connected to a network, there is what we call external and internal IP address, right? So what it does is that your ISP, your internet service provider, right? Let's take this as an internet service provider, is actually the one broke is taking in signals from all these devices, both your laptop, right, and then broadcasting those signals outside so that you can reach the internet, right? So when those you can see when those IP addresses that are allocated to the internal network infrastructure, right, are different from the external. So the router or whatever device you are using to connect to the internet will actually then mask the original IP address and use an external means to connect to the internet hereby giving you some sort of privacy, right? Because if an internal network IP address is exposed, it poses a lot of risk. A lot of devices will be affected, right? And a lot of devices can be compromised. So the private IP address is assigned by the router. As you can see the communication process, then it connects down to the internet. Why the um, public address is why the public address is assigned by the ISP, right? So that's your internet service provider. So once you connect to the internet, right, to connect to other web service on the internet network, right, the ISP provides a routing process with a different IP address, right, so that it can communicate properly. Then for communication within network, right? So this internal network is device that I mean the extra internal network is for device that are in, right? So they have maybe this one is IP address 198.86.62.1. This one is 198.2.3.4 within a subnet, right? So needs router for connection and needs a modem for connection. So ISP for this is your internet service provider. So it needs a modem. Modem more like routers. They provide internet service too alongside the router. The router is for provides internet service too, and a modem also provides. Those are kind of the similarities, but they have their differences, which we'll be seeing as we move on. So subnet mask, right? Subnet mask is a 32-bit number used in IPv4 networking to distinguish the network portion and the host portion of an IP address. It is like a key that helps routers and devices determine which part of the IP address identifies the network and which part identifies a specific device on that network, right? So the subnet mask helps us to identify host systems and network systems, right? Networking infrastructure. So, for example, maybe we have an IP address of 198.68.82.1, right? Now, 198.68.82.68 is what we call network address, right? Then the last portion, which is .1 or .2 or .3, is what is used to actually identify a host. So a subnet mask, which is ranging uh, about 255 addresses, right, is used to calculate different each different host in a particular system, right? Now we are, like I told you last time, we have segmentations we have broken down segmentations, or should I say subnet, right? Subnet are like segmentations of systems, right? So these systems now, the subnet mask helps us to identify each host that is on a particular IP address. So that's what subnet mask does, right? And subnet mask is um 255, which I'll be showing you in my Kali. Oh Jesus, my Kali is still updated. Yes, so let's move on. So we have what we call OSI models, right? OSI models and TCP IP models. So does anybody understand what OSI models are? Does anybody understand what OSI models are? Does anybody? If you do, please you can indicate and speak.
The thing simply indicates, or it's how do I put this? It indicates how different networks communicate over a network. Uh, so it's just
So
it's it divides network and all.
okay, so the OSI okay, the OSI model is a different. Should I say it's a it's a layout. It's a layer of how the internet works, right? So it's it helps to it helps model how each stuff that it actually communicates, right? Each devices that actually communicates. It helps them to understand the routing process to take when those communications are being made, right? So like we have in networking we have wired and wireless transmissions, right? Both we have wired and wireless transmissions, right? So what those wired and wireless transmission help us to understand is that there are so many stuff, right? So many things communicating, including um applications, network, data link, and physical cabling. So the OSI model is a model that helps you um, understand how communication is actually done on a network on the application level, physical level, and other level, right? But now, currently, OSI model is not really used as we have a new model called the TCP/IP, right? So instead of these 7 layers, the TCP/IP model helps us to route all these things right into different segments of the OSI model. So now the IP model. Are you with me? Can you hear me?
Yes, we can.
Can you hear me?
We can hear you. We can hear you.
Okay, so that's what it does. So we have the application layer which analyzes and applies network protocols based on this thing. That's the HTTP, the HTTPS, and all the rest. Then we have the presentation layer. It configures data, like send data. So I think this under the TCP/IP model, they yeah. Can you hear me?
Yes, we can hear you.
Yes, we can hear you.
Hello, can you hear me?
Yes, we can hear you.
So there is, according to TCP/IP model, there are different masking procedures, right? I think all this falls under. I've forgotten what these three falls under. Then the others, both the physical data link network and all, they still remain this thing. So yes, this one falls in the TCP aspect, right? And this network layer, right? They fall under the IP addressing this thing. Now, in application presentation and sessions, right? This we have different protocols that route them, like HTTP, FTPS, different for SMTPS, all of them. We have all this in the application layer because these ones are actually sending a lot of packet requests down to the server for you to receive emails and for you to have um, um, an interface. So this layer actually covers the UDP user datagram protocol. Yes, this layer covers user datagram protocol, right? Because this one, we know that packet can be lost. So every display you are seeing, everything you are seeing, all the routing process, all the HTML requests, all the stuff we are receiving from applications, all of them put together is what forms this UDP, this part you are seeing. Now, in applications, there are what we call sessions, right? Sessions are, if you know, we have cookie sessions, right? Session helps you to manage the login input and the logout input, right? So, in when you are doing a lot vulnerability assessment and penetration testing, you will discover that if sessions are not properly configured, it can lead to a full account takeover, or it can lead to misconfiguration, whereby something that is meant to be routing to this process is routing to another process. Why for now? In the application layer interface, right, of the OSI model that is covering the presentation and the sessions. Now you will notice that um, you notice that if you analyze the network properly, you notice a lot of distortions, right? We experience distortions. Like now, I was talking, some people weren't hearing me, right? If I was supposed to analyze the packet coming from this particular network, you see that what this thing does is that it's going to be doing a lot of retransmission, right? To fit in the gaps for the packet I have lost, right? So when we are diving into proper packet analysis, right, you will see that you will see all these things that I'm saying, that it is real. It is very real. So like if a communication is going over a network and it loses some kind of focus, what the TCP IP does is that it helps retransmit those stuff, right, to patch up for the data that has been lost at that moment. Note, under the user datagram protocol, data loss is always, packet loss is always constant. You will receive a lot of packet loss because due to instability coming from an ISP or anything. So what it does is that it just it's just like one area is cut. Okay, let me use this example now. If you are imagine your clothes gets torn, right? Your clothes gets torn in maybe the knee, maybe the yeah, especially crazy jeans, right? So now there are parts of threads that have been removed, right? That is what is making that tear happen, right? So what does the TCP does is that is the transport control protocol. It helps to patch that thing to make it look nice, right? So now if you see that patch, right, it makes it looks beautiful, right? So if you now put in a cloth inside and patch that particular area of the knee that has been torn, right, you will see that it's going to now look nice. So that's what TCP does. There will be a lot under UDP protocol, right? That's the user datagram protocol. It's going to do a lot of patching, so that you won't data can be retransmitted and routed properly, right? So that's what the TCP does. Uh we have protocols, right? Like I told you, we have the TCP IP, right? See it here, the Oga Gogo, and that helps route other processes, both the application layer, SMTP, FTP, HTTP, and Telnet, right? So this is the IP. Then we have PPP, that's SFTP, is Secured File Transfer Protocol, right? We have HTTPS. HTTPS is Hypertext Transfer Protocol Secure, right? We have Telnet, right? And Telnet is the secure version of SSA, that's secure shell. Then we have HTTP, insecure of HTTPS. This when you are using these protocols, right? Most times, um, most times when you are when you are sniffing a lot of credentials and interpreting them through Wireshark, you understand that all these things, you get them in plain text, but this, you get them in encrypted format, right? So protocols used in networking, we have TCP, IP, HTTP, we have FTP, we have DNS, we have DHCP, dynamic host configuration protocol. Now, this dynamic host configuration protocol helps to like be changing your IP from time to time, right? That's why it's dynamic. Then we have DNS, domain name system. That domain name system is a system that helps gives a particular site a, a IP and an internet protocol to be able to reach out to the internet to source for resources, right? So in the main shell, you'll be seeing google.com. But if you use passive reconnaissance tools like Dig, you can also use the IP address to host or run that particular website. Yeah, that's it. So we have wired and wireless connections, right? Network. So we have Wi-Fi, we have Ethernet, right? Wi-Fi is wireless, right? And Ethernet requires wire, right? So the speed when we are discussing wireless connection, sometimes it has low data transfer. And for the Ethernet, due to that it's connected directly, yeah, you experience a lot of fast, you experience a lot of speed while roaming the internet. Then we have reliability, suffers from signal interference due to many environmental factors. Yes, 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 yes. It's you can a Wi-Fi is not stable due to network interference, which can be rain, weather, sunlight, barriers, walls, even your building can be a barrier to wireless signal, right? Then for Ethernet, it always delivers consistent speed. Then we have security. Data flows need to be encrypted, and data doesn't need to be encrypted, right? Because it's going um, uh, um, over a bit. It's already, in fact, when data is going through a cable, just take note, it's already encrypted. Why? Because cables are running on that dynamic binary system, right? So cables only understand 0 and 1. So if you are transmitting a data through cable, you need to have to script that particular transmission that is coming from that cable, right? To be able to get the message. But if data are not transmitted, you can intercept those data and read them um, properly, right? We have latency. In terms of latency, is higher. Then is lower. Then deployment, easy to install and employ. Cabling is crazy. It's the installation is it needs a professional to install, right? It needs a professional to install cables, right? Common network attacks, yes. Um, we have we have malware, we have password attack, we have eavesdropping attack, yes, listening to people's conversation. We have phishing, we have man in the middle, we have cross-site scripting, DDoS, SQL injection, birthday attack, and drive-by attack. Malware attack, we are already conversant with malware attack is infiltration or using a malicious software to actually enter into a system or a particular network. We have password attack, which include brute force and all others, right? We have eavesdropping, right? Yes, eavesdropping is like connecting or entering a reverse TCP connection, which in the ethical hacking class you'll be learning properly, right? So ethical hacking class will be majorly focused on attacks and defenses to those attacks. Then we have man in the middle attack. Yes, man in the middle attack is when I sit in your network and I listen to every single thing you do. Yes, SQL injection, cross-site scripting, application attack, system attack, and all. So we have DDoS, right? We have DDoS and DDoS attack. DDoS and DDoS attack practically, they are kind of sophisticated attacks that yes, require you sending legitimate traffic or malicious traffic across a network, right? To actually deny the people, the end users, um, actually deny them service. The purpose of DDoS, it works everywhere. DDoS works everywhere. This is the only attack that nobody can literally stop. You just have to expand your ban to receive the a lot of traffic, right? And which most times companies cannot 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 afford to, because it's expensive to run most networking stuff, right? So DDoS actually comes and shuts everything down. That's DDoS for you. That's DDoS attack. So DDoS attack is focusing on shutting down internet infrastructures, network infrastructures, and all. So we have network security. How can you be secured over your network? We have firewalls, intrusion detection system, as IDS. So for people that want to know how to be defensive over network attacks, we have the SOC analyst part for you, right? So you learn SOC analyst part, understand what SOC analysis is all about, and all. So you learn intrusion detection, antivirus software, security policies, secure communication, data loss prevention, encryptions, and all. Yeah, we'll be looking at cryptography, but if you want to read crypto analysis and standard cryptography, right, you'll be right. So I think we've almost come to the end. Real life application, yes, we have remote cloud computing, remote work, smart homes and IoT, cybersecurity and all. In summary, um, recap types of devices. We dealt with OSI model, protocols, and how to secure a particular network. So if you have any question, you can ask. From on Saturday, right, we'll be diving more into standard packet analysis, right? And packet analysis is one skill you must have, right? In as much as you are planning to be an ethical hacker, yes, you must understand how network protocols work and how to also analyze malicious traffics, right? You must learn how to analyze malicious traffic and see where those traffics are currently coming from and identify malicious traffics that are in the network. Those things in on Saturday. So Saturday is going to be very, very intense as we'll be diving into um, network analysis and network forensics in general. So if you have any question, you can ask. So do you have any question? If you have any question, you can ask. So any question? Any question?
No question, no question, sir.
So you mean you guys understand?
I do. I don't know about the others.
So do you guys understand these things? So I've dropped a book by one of our top security researchers, OTW. please kindly look into the book. Right? It's called Network Basic for Hackers. Why I'm actually giving those books? They are expensive. Why I'm actually giving those books out is because you still need to dive in more. There are more into network that you cannot cover. Yes, you cannot. This is a boot camp. You cannot cover everything. So reading those books will help you analyze proper network. They will help you analyze network. You see network flaws and all that are within a particular network, right? So yes, it helps you analyze and become a better person in network forensics. I have practically done serious network forensics analysis from a client, right? For a client. So all these things helps you to build network experience. I've dropped those books in the channel. So make sure you go through those books properly, read them page to page, practice the things in your Kali Linux, and yes, launch them in real time. So practice them, write them, and make sure you um follow suit. So yes, I'll be giving your first assignment on network. Please on Friday or on Saturday, please make sure you guys take your proper learning and do your documentation as usual. Last week I was very busy, so I wasn't able to look and into most of the assignments, and I'll start grading each and every one of them. So yes, on Saturday, please make sure you write a detailed, comprehensive um, stuff of what you've learned and how to use them in real life, how you have been able to test them. Then today I'll give you one CTF to solve, right? I'll give you one CTF to solve. So I'll be expecting my feedback by Monday, right? So I'll be expecting feedback by Monday. So I'll be seeing you guys on Monday if you guys don't have any question. Right? Ibrahim, do you have any question?
Good evening, sir.
Yes.
Sir, I don't know. I came a bit late. I don't know. The first time you said you can maybe you will be uploading it on YouTube. So I don't know whether I can still get to this
Yes.
class on YouTube.
Yes, you can get them. All of them are being recorded. Yeah, you can get them.
The name of
I've not really. Yeah, I'll be
the
posting the links. Yes, I'll be posting the link. The name is actually HSC, right? I'll be
okay,
posting the link today, right, to the
okay,
channel, and you guys can subscribe to it,
okay, sir. Thank you.
right? So more if you want to learn more, I've dropped two books. The rest of the books, which are so the rest of the books are not really needed, except the one of cryptography, which I'll be dropping when we start cryptography properly. So yes, if you have any question, you can ask. If you want to understand deeper insight, please read the book that I have sent to the group, right? Yes. So if you don't have any question, we'll call it a day. Or should I dive more into network forensics? Let me see something. Just give me a minute. If my Kali has completed properly. So I'll be doing I think we should dive more into introduction to packet analysis. Right? Yes, I think we should do that today. So this is Wireshark. This is used for network analysis and network forensics, right? So it's used to capture live packets in a particular device, right? So yes, let's dive in and let's I want to capture packets from my personal device. So now we are going to be doing DNS, right? A lot of DNS stuff, right? So let's resume session, right? So if I come here to Wireshark to turn on the packet to capture my DNS request coming from the domain, you can see. Uh, there are no DNS requests currently, right? It's broadcasting ARP. Right, just hold on. I think to also include DNS requests. Let me go to so if you come over here, you see that it's still capturing a lot of requests. Right, this is how your network traffic are. Right, you still keep seeing a lot of stuff still going on. Right, this is what we call ARP broadcasts. Right, it's also a I think address resolution protocol. This is it's broadcasting that my IP address is kind of alive. Yeah, and sending signal. So my DHCP server is currently dynamically assigning a particular IP address to me, as you can see. So yes, let me stop. Let me start refactor. Continue without saving. Let me okay. Let an official website host. Okay, let's see. Hello by Adele. So if we come here, I think you should have started broadcasting. Uh, okay, it's still, yeah, it's trying to connect to my outside network. That's why it's still browsing. So it's trying to connect to the external IP address on the site I'm currently running. That's why it's asking for who is and who is this. Uh, let's see. I didn't implement any firewall. Uh, That's why you are not seeing anything DNS here. Even though you should be seeing domain name system, and you see the IP address that is actually broadcasting to or receiving a particular request from. But I don't know if I'm having a problem with my stuff. If not, we'll move it. Let me see. Let's see what we have in Warashi. ODM, gospel broadcast. I think my browser is not properly configured. That's why it's giving such issues. Yeah, it's not properly configured. So I'll set up my browser, and on Saturday we'll be doing packet analysis. Yeah, it's not properly configured. It's supposed to be transmitting all packets on my network. So without no question, we'll call it a day. Right, we'll call it a day.
Sorry, please. I do have a question. Um, so I noticed
Yeah,
we are using Firefox as a cybersecurity personnel. Shouldn't you be using more sophisticated browsers
yeah.
that help with or at least that limit
Like what?
online fingerprint? Something like maybe LibraFox. No, is it, I'm sorry, something like LibraWolf or maybe Brave or something that is a bit more secretive, than Firefox and all and Chrome.
DuckDuckGo or
Because
Brave.
yes, things like
Yeah,
that.
I use those. Yeah, yeah, I use those. It's because I use those browsers externally.
All right, thank you, sir.
I use those browsers externally to actually launch and run data. I use Brave. I use. I still have